400 Hz power systems are implemented in aircraft to enhance generator efficiency, reduce overall weight, and improve electrical performance. Several crucial factors should be considered. When selecting wire types and stranding, always opt for stranded copper wire that is specifically rated for 400 Hz applications. The stranded nature of the wire provides increased flexibility, enabling it to effectively endure the vibrations and movements commonly experienced in aircraft environments. To ascertain the precise wire gauges and materials required, always consult the receptacle manufacturer's specifications. Regarding wiring methods, it is imperative to strictly adhere to all relevant electrical code requirements governing the installation of 100 amp 400 Hz receptacles. For enhanced protection and proper support of the wiring, utilize conduits or raceways. It is also essential to ensure that the wiring is securely terminated at both the receptacle and any junction boxes incorporated in the system. Although specific installation instructions for Burton's 100 amp 400 Hz receptacles may not be readily available, the following general steps can be applied. Firstly, prepare the location by determining the exact placement of the receptacle and verifying that the wall or surface is capable of supporting its weight. Secondly, cut the opening by creating a hole in the wall or surface that is adequately sized to accommodate the receptacle body and its associated mounting hardware. Thirdly, install the mounting box by positioning an electrical box or mounting bracket that has been specifically designed to support the receptacle. Fourthly, run the wiring by routing and terminating the stranded copper wire to both the mounting box and the receptacle. Fifthly, mount the receptacle by carefully inserting it into the mounting box and securing it using the appropriate screws or bolts. Sixthly, connect the wiring by attaching the wire leads to the designated terminals on the receptacle, ensuring that the screws are tightened securely. Seventhly, test the installation by engaging a qualified electrician to conduct thorough testing, verifying that the installation complies with all applicable safety and performance standards. Ensure that the aircraft is properly grounded before initiating any connections or disconnections. Always wear appropriate personal protective equipment, or PPE, when handling electrical equipment. For any specific inquiries or clarifications pertaining to Burton's 100 amp 400 Hz receptacles, consult the Burton website or reach out to their customer support team. The efficiency gains from 400 Hz systems are realized through the use of smaller and lighter transformers, generators, and other electrical components. This is because the higher frequency allows these components to operate more effectively, reducing the overall size and weight of the aircraft's electrical system. The reduction in weight contributes to improved fuel efficiency and overall aircraft performance. Furthermore, 400 Hz power systems provide a more stable and reliable power source for sensitive electronic equipment on board the aircraft. This stability is crucial for ensuring the proper operation of navigation systems, communication equipment, and other essential avionics. In addition to the benefits mentioned, 400 Hz systems also help to minimize electromagnetic interference, or EMI, which can disrupt the operation of electronic devices. The design and installation of these systems must adhere to stringent safety standards to prevent electrical hazards and ensure the safety of passengers and crew. When working with 400 Hz power, it is essential to have a thorough understanding of the specific requirements and considerations involved. This includes proper grounding techniques, installation methods, and wiring practices. Ignoring these considerations can lead to equipment malfunction, electrical shock, or even fire. The selection of appropriate wire gauges and insulation materials is critical for ensuring the safe and reliable operation of the 400 Hz power system. The wire gauge must be sufficient to handle the current load, and the insulation must be capable of withstanding the operating voltage and temperature. Regular inspection and maintenance are essential for identifying and addressing any potential problems before they become serious. This includes checking for loose connections, damaged wiring, and other signs of wear and tear. When troubleshooting a 400 Hz power system, it is important to use appropriate test equipment and follow established procedures. This will help to ensure that the problem is identified accurately and resolved safely. The installation of 400 Hz receptacles should only be performed by qualified electricians who have experience working with these systems. This will help to ensure that the installation is done correctly and in accordance with all applicable safety standards. When selecting a location for the 400 Hz receptacle, it is important to consider the accessibility of the receptacle and the proximity to the equipment that will be powered. The receptacle should be located in a well-ventilated area and protected from moisture and other environmental hazards. The use of appropriate strain relief techniques is essential for preventing damage to the wiring connections. This will help to ensure that the connections remain secure and reliable over time. The labeling of 400 Hz receptacles and associated wiring is important for identifying the power source and preventing accidental misconnections. The label should be clear and easy to read. The training of personnel who will be working with 400 Hz power systems is essential for ensuring their safety and the proper operation of the equipment. The training should cover all aspects of the system, including installation, operation, maintenance, and troubleshooting. When working with 400 Hz power, it is important to be aware of the potential hazards and to take appropriate precautions to prevent accidents. This includes wearing appropriate personal protective equipment, following established safety procedures, and using caution when working with electrical equipment. The grounding system for a 400 Hz power system must be designed and installed in accordance with all applicable electrical codes and standards. A properly designed grounding system will help to protect personnel from electrical shock and prevent damage to equipment. The use of surge protection devices is recommended for protecting sensitive electronic equipment from voltage spikes and other transient disturbances. Surge protection devices should be installed at the receptacle and at other critical points in the system. The inspection and testing of 400 Hz power systems should be performed on a regular basis to ensure that they are operating safely and reliably. The inspection and testing should be performed by qualified personnel using appropriate test equipment. The documentation of all installation, maintenance, and repair activities is important for maintaining a record of the system's history and for facilitating future troubleshooting. The documentation should include dates, descriptions of the work performed, and the names of the personnel who performed the work. The design and installation of 400 Hz power systems should be coordinated with other aircraft systems to ensure that they are compatible and do not interfere with each other. This coordination should involve all relevant engineering disciplines, including electrical, mechanical, and avionics. The use of appropriate wiring diagrams and schematics is essential for understanding the operation of the 400 Hz power system and for facilitating troubleshooting. The wiring diagrams and schematics should be accurate and up to date. The selection of appropriate connectors and terminals is critical for ensuring reliable electrical connections. The connectors and terminals should be rated for the operating voltage and current and should be compatible with the wiring materials. The use of appropriate torque specifications when tightening electrical connections is essential for preventing loose connections and ensuring reliable operation. The torque specification should be provided by the manufacturer of the connectors and terminals. The proper routing and support of wiring is essential for preventing damage to the wiring and ensuring reliable operation. The wiring should be routed away from sharp edges and other potential hazards and should be supported at regular intervals. The use of appropriate cable ties and clamps is recommended for securing the wiring and preventing it from moving or vibrating. The installation of 400 Hz receptacles should be performed in accordance with all applicable electrical codes and standards. These codes and standards provide specific requirements for the installation of electrical equipment and are designed to ensure the safety of personnel and the proper operation of the equipment. It is essential to consult with a qualified electrical engineer or electrician to ensure that the installation complies with all applicable requirements. When working with 400 Hz power systems, it is important to be aware of the potential for harmonic distortion. Harmonic distortion can cause overheating of equipment and can interfere with the operation of other electronic devices. The use of appropriate filtering techniques is recommended for minimizing harmonic distortion. The maintenance of 400 Hz power systems should include regular cleaning of the equipment to remove dust, dirt, and other contaminants. This will help to prevent overheating and ensure reliable operation. The replacement of worn or damaged components is essential for maintaining the reliability of the 400 Hz power system. The replacement components should be of the same type and quality as the original components. The use of appropriate test equipment is essential for troubleshooting 400 Hz power systems. The test equipment should be calibrated regularly to ensure accurate measurements. The documentation of all test results is important for tracking the performance of the 400 Hz power system and for identifying potential problems. The training of personnel who will be maintaining 400 Hz power systems should include hands-on training on the use of test equipment and the performance of maintenance procedures. The safety of personnel should be the top priority when working with 400 Hz power systems. All personnel should be trained on the potential hazards and the appropriate safety procedures. The use of appropriate personal protective equipment is essential for preventing injuries. The grounding system should be tested regularly to ensure that it is functioning properly. The grounding system should be designed to provide a low impedance path to ground for fault currents. The surge protection devices should be tested regularly to ensure that they are functioning properly. The surge protection devices should be designed to protect sensitive electronic equipment from voltage spikes and other transient disturbances. The filtering technique should be designed to minimize harmonic distortion. The filtering technique should be appropriate for the specific application and the type of harmonic distortion that is present. The cleaning procedures should be designed to remove dust, dirt, and other contaminants without damaging the equipment. The replacement components should be of the same type and quality as the original components. The test equipment should be calibrated regularly to ensure accurate measurements. The documentation of all test results should be accurate and complete. The training of personnel should be comprehensive and should include hands-on training. The safety procedures should be followed at all times. The personal protective equipment should be appropriate for the specific task. The grounding system should be tested regularly and should be designed to provide a low impedance path to ground for fault currents. The surge protection devices should be tested regularly and should be designed to protect sensitive electronic equipment from voltage spikes and other transient disturbances. The filtering technique should be designed to minimize harmonic distortion. The cleaning procedures should be designed to remove dust, dirt, and other contaminants without damaging the equipment. The replacement components should be of the same type and quality as the original components.